Hi, this is Miss Cairo. This is math video lesson 3-2. And today we are going to be multiplying fractions times whole numbers to get fractions as our solutions. So for this lesson, you do need your activity book, and we're going to be working starting on page 73. And you also need your whiteboard materials and a pencil. So go ahead and gather those materials. And let's get started. Again, we're on page 73, and I'd like you to find the heading on page 73 and point to that red triangle and read along with me. The heading says, model the product of 1D times W. And again, those letters are called variables, and the letters are what we call variables in math, and those are going to represent numbers. So we're multiplying a fraction times a whole number again in this lesson, but the difference with this lesson is that we're going to be arriving at fractions as our answer. Okay, so let's go ahead and let's read the first problem and go ahead and read it along with me. I'm going to read it out loud. It says, Farmer Diaz has 3 acres of land. He plows 1/5 of this land. The number of acres he plows is 1/5 of 3 or 1/5 times 3. Before I read any further, let's go ahead and take a look at this. Our book nicely already set up the multiplication problem for us, 1/5 times 3. And go ahead and watch with me. 1/5 times 3, what we were learning in the previous lesson is how to draw an array and solve using an array to solve this problem. And we were drawing out rectangular arrays, and we were putting our whole number at the top and then splitting our array into how many pieces there were depending on our denominator. So for in this case, I split up into 5. But this array, and I said it a few times in the last video lesson, does not work unless the denominator is a factor of the whole number, meaning that we can make even groups based on with these two numbers. So 5 is definitely not a factor of 3. 3 only has 2 factors. It's just 1 and 3. That means I can't make equal groups from 5. I can't place any number here. That should have been a question mark. There's no whole numbers that evenly go into 5 groups of 3. So this array does not work for this problem because 5 and 3, again, they don't share any common factors. We're going to solve it, again, using a diagram or a picture. And we're going to do a few different steps for these diagrams. So these, just like with those arrays that we were practicing in the last lesson, these take quite a bit of practice. So I'd like you to follow along really closely with me during this video lesson, okay? Let's keep reading along with in our books and see how we're going to set up our diagram. It says the diagram at the right shows Farmer Diaz's land divided vertically into 3 acres. The dashed horizontal segments divide the land into 5 parts. The shaded strip is the 1/5 of the land Farmer Diaz plowed. Okay, so they already did the work for us, but I'm going to walk you through the steps. So what I'd like you to do is I'd like you to draw out this diagram with me on your whiteboard. So get your whiteboard ready. And what I'd like you to do, we're going to draw a rectangle that's fairly long and fairly wide. Okay? And we're going to go back to the problem. How many acres did Farmer Diaz have? He had 3 acres of land, okay? And this whole number in our problem of 1/5 times 3 was in fact, 1/5 times 3 was in fact 3. So at the very top, I'm going to leave a little space down here at the very, very top with some space in between. I want you to write the number 3, okay? And with this 3, since 1/5, again, 5 and 3 don't share any common factors, we're going to split this whole number of 3 into holes. And we're going to break it apart, splitting up each of the holes for 3 holes. So I'm going to create 1 hole here. Oh, that's not very even. Hold on. So we're going to break it up into 3 parts, each part representing one whole. So one whole here. So this is going to be 1 acre, one whole here and one whole there, 1 acre each. So what I'd like you to do is I'd like you to just draw 1, 1, 1 to represent 1 acre each. Okay, and our next step, they talked about it over here. They used dashed horizontal segments to divide the land into 5 parts. So basically, we're going to look at our fraction here of 1/5, and I'm going to be breaking up each whole into fifths. And I'm going to do it using vertical lines, and so are you. So I'm going to take this first whole, I'm going to split it up into 1, 2, 3, 4, 5 parts. So 4 dashed lines or 4 dashed horizontal segments to represent 1/5, 1/5, 1/5, 1/5, 1/5. So 5 fifths to equal 1 whole. And I'm going to do that for each of these wholes as well. So let's go ahead and continue. And I'm just going to continue all the way across. Here's 1/5 that breaks all my holes into part, 2/5 that breaks all my holes apart, 3/5, and 4/5, and then 5/5. Each hole split up into fifths now. And then it says the shaded strip is the 1/5 of the land that Farmer Diaz plowed. Well, we're going to go through this really carefully. I want to know what 1/5 of each of these holes shaded represents and looks like. So I'm going to just shade in that top part just like our book did. 1/5 of one hole looks like this. 1/5 of one hole looks like this. And 1/5 of one hole looks like this. And at the very end, we're going to be doing some labeling down here, and we're going to label how much of each hole we just shaded in. And I've said it a few times. So we just shaded in 1/5 of this hole, 1/5 of this hole, and 1/5 of this hole. And I want to know how much did he plow in all. So he had 3 acres. Each acre we took and broke apart into fifths. I'm going to go back and I'm going to add all these parts together, and that will arrive at, remember, with adding fractions, they have to have the same denominator. Denominator is the same for all of these. Our denominator is, in fact, 5. And our numerators, we're just going to add across. 1 plus 1 plus 1 is equal to 3/5. And the unit that we're using here is acres of land. And then it says, let's go back to our book, keep that drawing out. The drawing shows that taking 1/5 of the 3 acres is the same as taking of each acre and combining them. We can show this mathematically. So here's one way we might show it mathematically. 1/5 times 3 is equal to 1/5, and then breaking apart this 3 into 1 whole plus 1 whole plus 1 whole. And then when we go back and we use what we call the distributive property when we multiply 1 times 5, 1/5 times 1 plus 1/5 times 1 plus 1/5 times 1, or 1/5 of 1, 1/5 of 1 acre, and 1/5 of another acre, and 1/5 of another acre, just like we demonstrated with this diagram, is equal to 1/5 plus 1/5 plus 1/5, which is equal to 3/5. So 1/5 of 3 acres is, in fact, 3/5 acres. And there's our answer for that problem. All right. Thanks for working along with me. You can erase your whiteboard, and let's go down to problem number 1. And we're, again, talking about a farmer plowing land, different kind of scenario there. So number 1, go ahead and find that in your book and read along closely with me. It says, Farmer Smith has 4 acres of land. She plows 1/3 of her land. Divide and shade the drawing at the right to show the part of the land she plows. So they already set up a diagram with us. The multiplication sentence is already in your book. It's 1/3 times 4 that goes along with this word problem. 4 acres of land, plowing through 1/3 of them. We're looking for what 1/3 of 4 is. All right. So just like with the last problem, and you might want to refer back to your book to follow along with the different steps, They already set it up for us. We have one diagram here. They put 4 at the top, and then they split the 4 into one whole each. So we split it up into 1 plus 1 plus 1 plus 1. Okay, the next step, we're going to use horizontal lines, dashed horizontal lines to represent what 1/3 of each of these 1 acres look like visually. So this 1 acre here, I'm going to split it up into how many pieces to represent 1/3. How can I represent what a third of an acre is? Well, I'm going to look at my denominator here. It's 3. So I need 3 total parts. So I'm going to do a dashed line and a dashed line. Now I have one group, 3 total groups to represent thirds. Does yours look like mine? Go ahead and do this directly into your book so you have this as an example. Okay, and then the next step, we're going to continue this dashed line. Remember, anytime we're doing these diagrams, whatever we do to 1 acre, we're going to have to be doing for all the rest. So I did 1/3 over here already. I'm just going to continue this dashed line the whole way through the diagram, going through all 4 acres of land. Okay, so now I have 4 acres all split up into thirds. Next step, just like we've been doing in the last lesson, is to shade. And we're shading to represent what 1/3 of 4 is equal to. And what we're going to do is we're going to work 1 acre one at a time. So let's just pay attention. Don't ignore the rest of the acres. Let's just look at this one acre. I split 1 acre into 3 parts. How do I represent what 1/3 of 1 acre is? I have 3 groups. How many groups should I shade in for this 1 acre? Yeah, 1 group. So I'm just going to do this top one. I'm just going to do quick little vertical lines just like that. I have 1 group shaded out of a total of 3 to represent 1/3 of 1 acre. I'm going to have to do this for all 4 acres. Remember, she has 4 acres of land. She plows through 1/3 of them. So I'm going to shade in the 2nd acre. I'm going to shade in 1 part of a total 3 for my 3rd acre, or her 1/3 of an acre. 1 more group and 1 more group for this 4th acre. All the way through. Does yours look like mine? Okay, and then let me go back and let's make sure we follow the directions closely. Divide and shade the drawing at the right to show the part of the land she plows. Yep, we did. Okay, and then let's take a look at number 2. It says express 1/3 times 4 as a sum of unit fractions. Remember, a unit fraction is a fraction with what number as its numerator? 1. 1/3 times 4. And we did this on my page is kind of cut in half. Take a look. We also did this with the previous problem. 1/3 is in fact a unit fraction, and we're multiplying 1/3 times 4. Sum means what operation? Sum means the answer to an addition problem. Let's form an addition problem out of this multiplication sentence. Remember, with multiplication, you can also turn it around into repeated addition. How many times I'm going to take my unit fraction? We want unit fractions for our addition sentence here. I'm going to write out 1/3. So should you. How many times should I add 1/3 by itself to represent times 4? 4 times. 1/3 plus 1/3 plus 1/3 plus 1/3. 1/3 is a unit fraction. I just took 1/3 times 4 and change it around to repeated addition. Those are addition signs, and use it instead as an addition sentence. And now I can easily solve using number 3. The question is, what area does Farmer Smith plow? We can use number 2 to solve and number 1 to solve. So let's use both. In this diagram, remember, we're going to have a fraction as our answer. Our fraction, let's work with the denominator first. The true definition of a denominator is how many pieces do we split our 1 wholes into. So for just 1 acre, how many total pieces were there? 3. That's why we use those dashed horizontal lines. You wouldn't count all these pieces here. The common error for many 5th graders would be to count 3, 6, 9, 12 to say that our denominator here is 12. It's not 12 because there's you need to only be looking at 1 whole each. Denominator means how many pieces 1 whole was split up into. Okay, and then this is where it gets a little tricky. Our numerator, the true definition of a numerator in this case for a diagram, is how much did we shade in all? We are looking at a total of 4 acres. How many thirds of 4 did we shade in? We shaded in 4 pieces. So according to this diagram, we shaded in 4 thirds of the diagram. And just like we were working with in unit 1, we are never going to leave fractions in improper form. We would never in real life say that Farmer Smith plowed 4 thirds of an acre. We would turn it into a mixed number. And remember, what operation do we use to do that? Division. You would divide 3 into 4. Okay? And 3 goes into 4 one time with a remainder of 1, and we would turn our remainder into a fraction. This would be our numerator. This divisor would be our denominator, and our true answer would be 1 1/3. 4 thirds is equal to 1 1/3. 1 1/3 what? What area? What unit are we using? Acres. And again, I just solved it using just the diagram. Let's make sure that this is true with number 2 as well. A different way of solving this would be, again, using repeated addition. If I add across, the denominator stays the same as 3. 1 plus 1 plus 1 plus 1 is in fact 4, and we know that 4 thirds is equal to 1 1/3 acres. Okay? So again, 2 different ways of solving, got the same answer. Our answer, do you have this in your book? What area does Farmer Smith plow? She plowed 1 1/3 acres of land. All right, let's keep going. Let's do number 4. Go ahead and read along with me. It says Farmer Hansen, oh my gosh, we're still working with farmers here. Farmer Hansen plows 1/7 of his 2 acres of land. What area does he plow? And we are going to use 2 ways to solve this problem. Let's draw a diagram and solve that way first, and then we'll use another way. So go ahead and draw out. Let's do this directly in your book so that you have a example to be referred back to when you're doing independent work. So draw a diagram that's rectangular, but make sure that you have enough room inside to be splitting it up into different groups. I'm already previewing the problem. I'm going to go back and make mine bigger. Okay, so now Farmer Hansen, I'm going to circle these key numbers, 1/7 and 2 acres. So he has a total of 2, or he or she has a total of 2 acres. At the top, remember, I'm going to put, let me change my color so it's a little more clear. 2 acres total. And remember, 7 and 2 do not share common factors, so we are in fact going to have to be using this diagram way to solve. I'm going to break 2 acres of land into 1 hole and 1 hole over here. 1 acre and 1 acre. I'm going to use an addition sign in between to represent that they are representative. 1 plus 1 equals 2, and I'm going to split it up into 2 pieces with a solid line. So are you. Does yours look like mine? Great. And now let's go back to the fraction and let's decide how many total pieces am I going to be splitting up this 1 acre right here. Well, let's look at our denominator. What's our denominator for 1/7? 7. So how many total pieces for are we going to split this diagram or this this acre into? 7. And remember, we're going to use dotted lines or slashed horizontal lines. And the reason being is that it's not going to confuse us when we go back and solve when we're finding out what the denominator is. Okay, so really carefully, you're going to form 7 different groups. Okay. 1 acre split up into 7 groups, 1/7 of land. I should have warned you guys, let's just continue that dotted or slash line all the way through to the end of our diagram. So continue those lines. Mine's getting a little messy. I hope yours is a little neater than mine, but no problem. We can go back and label. All right. If you need a pause, go ahead and pause. If not, let's keep going. Let's do some shading. Let's go 1 acre by 1 acre. How can I shade to represent what 1/7 of 1 acre is? 7 total groups, how much should I be shading in? Our numerator here is 1, so I'm gonna just shade in 1/7 here. I'm gonna label that 1/7 since mine's a little messy. And I'm gonna continue the whole way through my diagram. The second acre, she also or he also shades 1/7 of an acre. And now what area, oh, sorry, it is a he. Woo, okay. What area of land or what area does he plow? Well, let's use the diagram to help us. Let's draw out a fraction bar and let's decide what's the denominator here first. Remember, denominator, how many total pieces is just one whole split up into? Each whole split up into 7 pieces. And then our numerator, how many pieces did we shade in all? We shaded in 2 pieces. So according to our diagram, 2/7 is the answer. 1/7 of 2 acres is 2/7. Let's make sure that's true with changing this multiplication sentence into repeated addition. Go ahead and find a space. I'm going to do it all the way down here. You can do that. 1/7 times 2 is the same as we can take this number and add it together as many times as we need to represent times 2. So let's write 1/7 first. How many times should I add 1/7 to itself to represent that I'm multiplying it by 2? Just 2 times. 1/7 plus 1/7 is the same as 1/7 times 2. And then when I multiply, or when I add across, 1 plus 1 is 2, and 7 stays the same, 2/7. 2 different ways of solving. We just got it. 2/7 acres. 2/7 acres of land is how much Farmer Hanson plowed. All right. And then lastly, I just wanted to quickly preview with you guys. Let's skip number 5. Go ahead and go to page, what page is this? Page 74 really quickly. Multiply by a non-unit fraction, which, oh no, let's go down here. Circle the fractions on the number lines to help you multiply. 1/7 times 2. Oh my gosh, that's what we just did. Other than the grid, we can also use number lines to solve this. And our book nicely already split up the number lines for us. We're going to be doing some circling to represent what each of these multiplication sentences are. Okay, so take a look at 7a, 1/7 times 2, or what is 1/7 of 2? Take a look at the number line. We have 0 here, 1 here, 2, 1 whole and 1 whole. And each whole is split up into how many parts? 7 parts. We're going to go whole number by whole number, splitting or circling based on what our fraction is. So for this 1 whole, if it's split up into 7 pieces, how many pieces should I circle to represent 1/7? Just 1 piece. So go ahead and do that with me. So 1 whole is split up into, or is circled, 1/7 is represented, and we can even label it 1/7. And then for this whole, representing our second whole here, split up into 7 pieces. Again, how many 7s should I circle to represent 1/7 of my second whole number? Just 1 part out of a total of 7. And I'm going to label that, here's another 7. And just like we were doing before, we can look at this as repeated addition. What's 1/7 plus 1/7? 2/7. We just shaded in 2/7 of this of our number line that represents 2 wholes. 1/7 here, 1/7 here. Denominator is how many pieces 1 whole split up into. Numerator represents, in this case, how much is circled, 2. Okay, and then really, really quickly, let's do B. 3/7 times 2. All right, so we're looking again, 1 whole here, 1, 2, 3, 4, 5, 6, 7 whole piece or 7 pieces. We're working with a different denominator here. How many pieces should I represent, or should I circle to represent 3/7? How many pieces? Yeah, 3. So I'm going to count. I'm going to start here. 1, 2, 3. I'm going to circle all 3 of these pieces in one big circle, and I'm going to label it 3/7. That's just for one hole. That would be the answer if it was 3/7 times 1, but it's 3/7 times 2. So I'm going to go over here for my next hole. 7 pieces. How many am I going to circle to represent 3/7? Again, 3 pieces over here again. I'm going to label it 3/7. Let's use some repeated addition really quick. What's 3/7 plus 3/7? 6/7. And is that true with my circling? Yep, 1, 2, 3 pieces. 1, 2, 3 pieces. That equals 6. 7 is our denominator. That represents how many each hole split up into. Great. Thanks so much for following along. That's lesson 3-2. More strategies are to come, and then we're going to get into what are you noticing to be shortcuts of possibly solving these problems, or how do we just solve these mathematically without number lines and without grids? That's the question to come soon. Thank you.